AI is moving from experiments into enterprise infrastructure. That shift demands more than innovation. It requires governance, security, compliance, and trust. In this masterclass, we'll connect those disciplines into a practical strategy for scalable, responsible AI adoption. We'll approach the course as an enterprise transformation journey. You'll start with the AI shift and the rise of shadow AI. Then you'll build the foundations for governance, risk, security, compliance, and trust. Finally, you'll turn those capabilities into a practical roadmap and capstone application. The course is designed as a progression, not a set of disconnected topics. We begin with what changes when AI enters enterprise systems: behavior, decisions, risk, and trust. Then we assess where the organization stands using questions, maturity models, matrices, and risk maps. From there, we examine operating models, governance, security, compliance, and architecture. The work culminates in consulting-style deliverables you can adapt for real enterprise environments. This course can meet you at different levels, but it works best when each idea is connected to an enterprise setting. If you are newer to the topic, move in sequence and let the foundations build. If you already have experience, go deeper where the material connects to your role while keeping the full operating model in view. If you are advanced, use the course as a toolkit. Capture reusable artifacts as you go: risk questions, control ideas, governance patterns, and architecture decisions you could bring to a real team. Traditional software is deterministic. With the same rules, input, and environment, you expect the same output. Testing is largely about confirming that expected behavior. AI systems are different. Their outputs can vary because model behavior, context, data sources, prompts, and operating conditions all influence the result. Quality assurance therefore shifts from checking one correct answer to managing acceptable ranges, monitoring uncertainty, and designing safeguards for unexpected responses. The key shift is that AI does not simply follow a fixed path. It can generate content, learn from patterns, and trigger actions through tools or APIs. That makes it powerful, but also less predictable. A traditional workflow can be tested against one expected result. An AI workflow must be evaluated across many possible outcomes, including accuracy, relevance, safety, bias, and resilience. The assurance question becomes, can we trust it as conditions change? An AI system is never just code. Its behavior emerges from infrastructure, data, people, policies, workflows, and oversight. Change one of those elements, and the system changes. A model trained on weak data, placed in a flawed workflow, or governed with unclear accountability can create risk even if the technology itself is advanced. That is why enterprise AI requires socio-technical thinking. We design the algorithms, but also the roles, controls, incentives, and feedback loops around them. Traditional governance often treats AI as something you approve, review occasionally, and gate before launch. That is not enough when models change, data shifts, and users adapt the process around them. Continuous oversight follows AI across the full lifecycle: ideation, data, testing, deployment, monitoring, and retirement. The goal is not more bureaucracy. It is timely visibility, clear ownership, and feedback loops that detect and correct risk while the system is operating. Trustworthy AI has to be designed into the system, verified before release, monitored in real use, and governed through clear accountability. This is where policy becomes action: controls, evidence, review points, escalation paths, and ownership. Risk does not stop at launch, because data, prompts, users, integrations, and regulations can all change. Effective governance makes oversight part of how AI operates every day. AI impact mapping connects where AI touches the enterprise with what that means for risk and action. Start by identifying the affected processes, decisions, and data. Then classify the type of AI use: assisted, automated, or generated. Each level changes the control expectations. From there, evaluate business impact, legal exposure, security needs, and governance requirements. The goal is prioritization, so teams focus oversight where AI creates the most significant consequences. Once impact is mapped, the next question is where AI is actually being used. Adoption heat mapping compares usage with risk. helping teams see which functions need attention first. Shadow AI discovery looks for activity outside approved channels, public LLM access, unofficial copilots, unauthorized automation, and unmonitored tools. Evidence may come from SaaS extensions, API activity, expense claims, IT service requests, and user surveys. Together, these signals become a prioritized governance backlog. With usage visible, the next step is mapping the risk landscape. AI risk is not a single category. Technical issues such as hallucination, drift, prompt injection, and data leakage can quickly become legal, ethical, operational, or business consequences. A weak model may turn into a compliance issue, a customer trust issue, or a process failure. The value of this pattern is shared language. It helps architecture, security, compliance, legal, and business leaders see the same risk picture and decide who owns what. A common failure mode is treating AI as just another tool. It is not. AI needs process ownership, data boundaries, monitoring, and explainable decisions. Avoid open-ended access to sensitive information and avoid invisible automation. The practical rule is simple. Connect AI to business workflows, but wrap it with controls, accountability, and review. As you move forward, remember that AI is not ordinary SaaS. Its risks come from probabilistic behavior, hidden data exposure, and decision influence. Start by finding shadow AI and risk hotspots. Then assign ownership, monitor outcomes, and govern every AI-enabled business process before scaling automation.